All right, let's look at integration of the form, the integral of f prime x, f of x raised to the power of n dx. All right, the essence of this form is that f prime x is the first derivative of f of x. So you have a function which is raised to an external power being multiplied by the derivative of the function. So the general format is you have a function raised to an external power being multiplied by the derivative of the first derivative of the function. If an integral is of the form f prime of x, and in bracket you have f of x raised to an external power n, the integral becomes f the integral becomes f of x to the n plus 1 divided by the new power plus c. Alright, so in a sense what it does is that it becomes sort of like a power integral, where you raise the function, raise the power of the external power of the function by 1 and then divide by the new power. What happens to the derivative? Remember, whenever you integrate, you should also divide by the derivative of the inside function. So the two derivatives are sort of going to cancel out each other. All right. All right. This says, example 44 says, find sine, the integral of sine x cos squared x dx. All right. If you differentiate cos, you're going to get sine. So if I sort of multiply, let's do something like this. Sine x cos squared x dx. Remember I said that if I differentiate cos, I'm going to get what? Sine. I'm going to get minus sine. So in essence, what I've basically done is that I ensure that this is now in the form where I'm multiplying a function cos x raised to an external power, which is 2, being multiplied by the derivative of the function, because the first derivative of cos x is minus sin x. When you integrate this, you're going to get, right, but the minus, if it's going to come a power integral, it's going to be what? Come cos 3x, so the power increases by 1, and then you divide by the new power 3. And remember, we should what? Also what? Divide by the what? The derivative of the inside function. The inside function is cos x. If you divide by cos x, if you differentiate cos x, you're going to get minus sin x. So the two minus sin x are going to cancel each other. Plus c. All right. Example 45. Again, I'm going to multiply by minus sine 2 times sine x minus sine x. Cos 6x is the same as saying cos x all raised to the 6th power. So this would be what? Cos 6x minus sine x is the first derivative of cos x. So I'm going to raise the power to cos 7x, right? But the first minus, divide by the new power, which is 7, and then I'm going to add the constant of integration c. So what happened to the minus sin x? Whenever you integrate, you're supposed to divide by the differential of the inside function. If you differentiate cos x, you're going to get minus sin x. So the minus sin x cancelled the minus sin x. Here, similar idea. Matter of fact, the same thing. It's just that the power here is n cos n x. So it's going to be increase the power by 1 cos, right, by the first minus n plus 1 x plus c, and then divide by the new power, which is n plus 1. All right, here, if I differentiate sine, I'm going to get what? Cos. So again, now this is in the same format where I have a function sine x being raised to an external power n, and I'm multiplying that by the derivative of the function. The first derivative of sine x is cos x. In this case, I'm going to increase the power of the sine by 1. So it's sine n plus 1 x divided by the new power n plus 1 plus c. The cos x, you'd also have to divide by the derivative of the inside function. If you divide sine, you get cos. The two cos x are going to cancel each other. Similar arrangement. Sec square x is the differentiation of tan x. So I'm going to increase the power of tan by 1. So it's tan n plus 1 x divided by the new power n plus 1 plus c. Remember, whenever you integrate, you should also divide by the differential of the inside function. The inside function is tan x, and if you divide tan x, you're going to get sec squared x. The two sec squared x would cancel. All right.